If you are going to take a biochemistry class or study anything beyond biochemistry that's related to proteins, you're going to want to memorize 3 and 1 letter codes for all of the common amino acids. You're going to want to memorize all of these structures. But most people, it doesn't serve to have this memorized. But that doesn't mean you have to be ignorant about chemistry of proteins. You can quickly pull out a guide or a reference to the 20 common amino acids. You can find it on a website easily. For my classes, you should have one printed out that shows you all 20 and lists their names and 3 and 1 letter codes for each. So when you get a structure, you see a structure, and this is a form that's written that makes it really easy to see the side chains. We can just, at a glance, see there's a side chain, there's a side chain, there's a side chain. It may not always be so easy, but even on more complicated structures, if you can find the backbone, you can isolate the side chains. Then you look at it, and you figure out, what is this? Well, here we've got phenylalanine, and this one is one of our aliphatic carbons. It's leucine. There's an amide. That means it's asparagine or glutamine. It is asparagine, and I can tell because it's just got the 1 carbon and then the amine. Glutamine has 2 carbons before you get to the amide, before you get to the amide. So we've got phenylalanine, leucine, and asparagine, and then it's just trivial to look and see phenylalanine is PHE, leucine is LEU, asparagine is ASN. And the 1 letter codes may not be as intuitive for some of them, like asparagine is N and not A. But they're not hard. You just look them up. And it's that simple to read. If you were to see these letters or these 3-letter codes, you could go back the other way and see what the chemicals are that each of them represents. And then, since you know things about aromatic groups, you can say, oh, this is nonpolar. It's got pi electrons that are shared throughout. This is aliphatic and nonpolar, not going to be very reactive. This is an amide. It could do reactions that amides do. It's got the carbonyl, so it's going to be polar. It's got the NH2, so it's hydrogen bonding. And all of this you can get from just looking at the symbols or names and going back to what you know about organic chemistry.